A couple of years ago, I did a 125-mile boat camping trip on my solar-powered Boston whaler. It was a blast, but the 13-foot whaler hull wasn't exactly ideal for this kind of adventure. It's designed to be a high-speed planing hull, but I was using it as a low-speed displacement hull. Because of that, my cruising speed was only about 3.8 miles per hour, even with 1,000 watts of solar panels on board. If I had been using a boat designed for maximum efficiency in displacement mode instead of a planing hull, I could have cruised a lot faster and probably gone a lot farther too. Someday I'd like to build a big folding solar-powered catamaran for long-distance trips, but at the moment I don't have a big enough workshop, so I'll have to save that project for later. I do, however, have just enough room to build a 14-foot catamaran. That's the perfect size to cruise around the local lake, but it's a bit too small to be my idyllic solar-powered camping vessel. Over the past couple summers, I've had a ton of fun with powered paddleboards. There's something about their simplicity and being so low to the water that makes them really enjoyable. In this video, I'm going to build a minimalistic catamaran that will have a similar feel to riding a powered paddleboard, but be faster, more efficient, and more capable. Step 1 was to hop into Onshape and design half of a hull. Then I split it up into sections that would fit in my 3D printer. That's right, we're 3D printing two 14-foot boat hulls. The design is symmetrical, so we can just mirror it. And there you go, a super narrow, efficient hull. This design was partially inspired by rowing shells. These boats are just about as efficient as it gets when it comes to displacement hulls, but I wasn't able to copy them exactly because I need more buoyancy for my given 14-foot length constraint. My hulls will have a lower length to beam ratio, which means they'll be a bit less efficient, but that's okay because they're still going to be way more efficient than my whaler or a powered paddleboard. Most of the hull is just a closed tube, but I added these recessed areas for the batteries, and a sub-recessed area to kind of act as a bilge. In hindsight, adding both of these recesses was a real mistake. You'll see why later. They're sized perfectly to fit these 25-volt 100 amp hour batteries. For mounting the deck, I added rectangular cutouts for pieces of wood that the deck will bolt onto. The next step was weeks and weeks of 3D printing. I'm using lightweight PLA for this project. It's the stuff that foams up in the nozzle so the parts weigh roughly half as much as they normally would. I printed one of the hulls on the Prusa XL and Mark IV's and the other hull on the FL Sun S1. I couldn't commingle parts between the two printers because the S1's calibration was really bad, so those parts wouldn't fit on the Prusa's parts. But anyways, I chose to use a gyroid infill so that the parts have one continuous internal volume. This means that it is possible for the entire hull to fill up with water and sink, although if the outer composite skin does its job, that won't happen, unless there's some serious damage. What's more likely is that there will be a slow leak, and having the inside be one continuous volume will make it much easier to drain the water out in this case. If I had used a standard grid infill, draining any water from the hull would be nearly impossible. I did have the idea that I was going to fill each section with expanding polyurethane foam for backup buoyancy, but doing this to every section would have added a ton of weight and cost, so I only ended up doing it to a few of them. After 3D printing, I had to do several hours of post-processing. This involved sanding off the stringy bits and drilling out all the alignment holes. I also cut holes in the outer wall of each part that all line up. This will allow water to drain from section to section, if I do end up needing to empty it all out. Heaven forbid. Now it's time to make the wood posts that the deck will mount onto. By the way, if you want to access this CAD model, it's available at the Onshape link in the description. Just sign up for a free hobbyist account and then you'll have access to all my projects. To make these deck mount posts, I started by cutting out some pieces of wood on the CNC router. There will be 2 of these on each hull, 4 in total. Those just got a quick sanding, and then I plugged the holes to keep out epoxy and started wrapping them in fiberglass mat to add strength. In hindsight, I should have just skipped the fiberglass and gone straight with carbon fiber, but oh well. I did end up adding a layer of carbon fiber on the outside for additional strength, and a layer of peel ply over that, and some breather cloth over that. Once all 4 were laid up, I put them in a vacuum bag to compress all the fibers together while the epoxy cured. After that, I peeled off the peel ply and was left with a big carbon fiber popsicle. Then I used a small plywood stencil to locate the hull positions and open them back up. Now it's finally time to start assembling the hull sections. I used Gorilla Glue to stick them all together. The hull mount goes all the way through so that it transfers most of the load down to the bottom skin of the hull. I'm using carbon fiber rods to make sure each section is perfectly aligned while the glue cures. And the next section just slides on. The Gorilla Glue foams up a lot, so it required some trimming. And basically I just repeated this process for all subsequent sections, slowly building up the boat chunk by chunk. There are 20 sections per hull, 40 sections for the whole boat. After all the glue cured, I had to do quite a bit of trimming and sanding. At this point, I kept each hull in 3 sections, partially because if I had glued the whole thing together, it wouldn't fit out the door, but also because this lightweight PLA is not very strong, especially since I printed it with really tall layer lines. So if I had glued the whole things together, they probably would have just snapped in half under their own weight. Speaking of weight, each hull weighs 6.25 kilograms, and that includes the wood posts. So both hulls together are up to 12.5 kilograms or 27 pounds so far. If I could go back in time and smack myself for making this intricate slot geometry in the bottom, I would. But that's going to be really hard to fiberglass over. There's a lot to be stressed about these days, like your 3D printed boat cracking in half. My grandpa always told me when you're feeling stressed, just suck it up and take a hike. But of course, taking a hike doesn't really help. Even a tranquil paddleboard outing doesn't always solve my stress. On Instagram, I saw that someone had an emotional support duck, and I thought, hey, I could use an emotional support duck. So that's what I'm doing, just out here trying to find my duck. Here, duck. Wah, wah, wah. Ducks, I've finally found them. Oh, there they go.
6.5 hours later.
Turns out ducks are hard to catch. I should have brought some French fries. I'm going with BetterHelp instead, who is also the sponsor of this video. Even as mental health awareness grows, 62% of adults believe that society discourages people from getting help. And surprisingly, 37% of Gen Z believe that seeking therapy is a sign of weakness. To help end the stigma around mental health support and encourage people to get help from a licensed therapist, I'm joining forces with BetterHelp. As opposed to ducks, even if I could catch one, licensed therapists listen to you, suggest changes, and give you techniques to help you make improvements to your life. BetterHelp's mission is to make starting therapy as easy as possible. If you think you could benefit from talking to a licensed therapist, click on the link in the description or go to betterhelp.com/rctestflight. You'll be matched with a therapist in as little as a few days. Using my link also gets you 10% off of your first month. Going to therapy is a sign of strength, not weakness, so try it out for yourself with BetterHelp. Now back to the build. 3D printed parts usually don't come out perfect, and each section didn't line up as perfectly as I had hoped, so I ended up having to do some fairing. I'm using epoxy-based fairing compound here to fill most of the low areas. Next, it was time to punish myself for designing these battery cubbies by fiberglassing over them. Oh yeah, I like my new scissors. They're pretty good. First, I prepared a bunch of fiberglass strips of all different sizes, and then started laying them into the recesses. Just like paper mache, only much nastier. I tried to do at least 2 layers of 6-ounce cloth over every part. Laying glass down over all these compound curves was the worst. Really just a big waste of time in hindsight. And then of course I had to go back and sand all the sharp bits, and I occasionally sanded through in a lot of spots. So I had to mark those areas and go back and cover them later. Eventually I got it all done, and it was time to move on to gluing the whole hull together. To do this, I made a long skinny table and made sure each section was aligned at the right height. These need to slide together now before that glue drops. Oh, and it dropped. Too late. There we go. Slide together. Okay. Then I used a strap to pull them all together while the glue cured. And I used some shims to make sure it was all aligned straight. After getting it all together, it became obvious that some sections were not very flat. I think this was due to temperature variations during 3D printing, and who knows why else. So I ended up putting on quite a bit more fairing compound and sanding that down flat. Here I'm wiggling one end of the hull. You can see how it bends quite a bit. So now it's time to stiffen it up. I started with unidirectional carbon fiber. This is going to give the hull lots of strength in the fore-aft direction, hopefully to prevent it from breaking in half. I wetted out the 3D prints with epoxy and then rolled out the uni, and then finished wetting all that out from the top. After that, I did another layer of uni next to the first one, and another on the other side to make it symmetrical. After wetting those out, I added another layer of uni in between the previous 2 layers. Wetted those out, and then added one final layer straight down the middle. So at its thickest, the uni is 3 layers deep. That should be plenty strong. And to help smooth everything out, I added a layer of peel ply, and carefully used a heat gun to help the peel ply absorb some of the epoxy and lay down flatter. To speed up the curing process, I used a bunch of pieces of music wire to make a tent over the boat, and then I had a space heater blowing hot air up into it. That got the boat up to 90 degrees, which certainly helps. Now it's not as floppy of a floppy noodle. Starting to get some rigidity to it. After the epoxy cures, the peel ply gets peeled off and it leaves a nice matte surface finish underneath that subsequent layers of epoxy will adhere to nicely. There are some gaps, but that's okay because those are just going to get covered up by the next few layers of carbon. I did do a little bit of sanding at this stage because some of the white cross-linking threads were sticking up too high, but those were pretty easy to sand down. I also ended up doing a shorter layer of uni on the sidewalls. Next, it was time for the top. I did one strip of uni down the middle with shorter ones on either sides of the deck mount, then cured it. Then came another layer on the side. I sanded down all the cross-linking threads, and then I did some perpendicular uni to strengthen the deck mount area. After that, it was finally time to start laying down the carbon fiber weave. I'm using 200 gram per square meter plain weave. This stuff will basically make up the skin of the boat. Same as before, I put peel ply on that and used a heat gun to smooth it all out. Next came the hard part, which is having to wet out the fabric over all these stupid curves. This is where I was really wishing I could go back in time and smack myself in the face. This boat would have been so much easier to build if it were just one continuous tube. But I stuck with it. The carbon was extra important in this area because it's the center of the hull, so it's experiencing the most stress when a wave is trying to snap the boat in half. And by the end of it all, I think I added enough strength. The carbon is 3 or 4 layers thick in this area. I guess I didn't add peel ply in this area because it would have just been a lot more work. I'll just need to sand this lightly before I put more epoxy on it, otherwise the new epoxy won't stick. Here's some more carbon fiber going on top, and then some more around the deck mount. The deck mounts are where all the load is going to be coming from, so it's important that we really beef those up. Here's a layer going over the top of the nose, and after that I had to try and wrap the weave around the tip. This was definitely a bit of a challenge. As you would expect, it ended up with lots of gaps and crevices, but that's nothing a bunch of sanding and fairing compound can't solve. Next, it's time to prepare the bottom for plain weave. After doing a bunch more general sanding to remove any stray high spots, I mixed up some fairing compound and started smearing it onto the rough areas. The goal here was to smooth out the gaps in the uni so that the plain weave would lay flatter over top. It might have been better just to skip this step and do more fairing over the final plain weave, but I'm not really sure. Once the fairing compound cured, I gave it a quick sanding with rougher grit sandpaper. I still wasn't very happy with how smooth it was, so I went back and added some more fairing compound over the rougher areas. At this point, I was starting to wonder why I didn't just build a negative mold to make the holes out of, rather than just doing it like a surfboard. But finally, the bottom of the holes were ready for plain weave. Oh, wow. That's a lot of money. I trimmed the carbon fiber to cover the bottom and the sidewalls. To assist in getting the carbon weave to adhere to the bow, I 3D printed these mold form things that fit perfectly over the nose, plus another 2.5 millimeters to make room for the composite. I prepared those with wax and PVA so that the epoxy doesn't stick. Back to the carbon. I began to wet it out with epoxy. Usually I first wet out the underlying surface with epoxy, but rolling up all this carbon seemed like too much work, so I decided to just try and fully saturate it from the top. This ended up being a huge mistake, as you'll see. All this carbon took quite a while to wet out, but I finally got there, or so I thought. It appeared to be fully saturated, but I had not yet done the tips. I started by cutting the overhanging bits and wrapping them around the front of the bow. So that gives us 2 layers over the bow, but the tip is much more tricky. And the tip needs to be strong, because if I run aground, this is going to be what hits first. So I started laying down lots of little carbon strips, but the problem is that they don't want to stay down on their own. So once I had added quite a few layers, I smushed them all down with the tip mold that I had previously prepared. So I've got some bungee cords putting tension on these mold blocks to hopefully keep all those fibers pressed down. Next, I laid down peel ply over all the carbon that was still wet, and I used a heat gun to help the peel ply absorb extra epoxy from the carbon fiber. And if you look very closely, you can see the problems starting to emerge. I think what might have been happening is that the heat gun was causing the peel ply to shrink a bit, and it was scrunching up the carbon as it shrank. This could have been due to the fact that I didn't pre-wet the surface before laying down the carbon, so it's possible the underside was dry in a few areas and it wasn't sticking down to the hull very well. This became a mad dash to try and get the carbon to lay down, but since I was using a heat gun, the epoxy was curing quickly. Any bubbles that I would smush down would just pop right back up after a few minutes. Eventually, I ended up just yanking off the peel ply so that I could try wetting down the carbon more. This appeared to be working at first, but after a while, many bubbles slowly re-emerged. So that sucks a lot. This has been a disaster. So what I'm going to have to do is wait for the epoxy to fully cure and then sand off the lumps and then put fairing compound down and try and even it all out that way. But on the bright side, my tip molds worked okay. The underlying carbon definitely wasn't pretty, but it was quite thick and strong. I'll be able to easily sand these down and use fairing compound to smooth them out. But next it was time to sand off all those horrible bubbles. After closer inspection, it did indeed look like the carbon was just not wetted out well enough in those areas. Lessons learned. After a lot more sanding and closer inspection, I was able to get rid of all the areas that weren't fully wetted. And man, having to sand this much carbon is terrible. You should really try to avoid having to do this at all costs. So now we just have to fill in these holes. To do that, I mixed up more fairing compound and carefully filled in all the holes. And of course with that came a lot more sanding to remove all the excess fairing compound. That left us with a pretty decent surface, but since that layer of carbon weave had been severely degraded by the holes and all the sanding, I decided to lay down one more additional layer on top of that. This time I was sure to wet the hole with epoxy before unrolling the carbon. Luckily this time the application was much more uneventful, and I also ended up not covering the entire thing in peel ply. Mainly just because I ran out of peel ply. Now the boat was structurally sound, but the surface was still far from perfect, so to hone it in I did quite a bit more sanding and fairing compound. And even more sanding. And after that, the bottom was ready for paint, but the top still needed some work. In order to strengthen the deck mounts, I made some fillets where they attached to the hull. Then after the fairing compound was cured and sanded, I started laying down carbon fiber, wetting it out layer by layer, hopefully making these posts strong enough not to just rip out of the holes. And eventually it ended up looking like this. I think they will be plenty strong. After sanding the new carbon, it was finally time to start painting. I'm using 1 part polyurethane topside paint for this boat. This is the polyurethane primer going down. This boat is not going to live in the water for its whole life, so topside paint should be just fine. After rolling on the first layer, it became clear that I did not do enough surface prep. This is what happens when you don't use peel ply. Hey, get off of there. You have all these little tiny holes in between the carbon fiber weave, and the paint just does not go in there. Ugh, yeah, I should have used more fairing compound. My hope was that the paint would be better at filling gaps, but it clearly wasn't. At this point, I was wishing I would have used a thicker paint like epoxy-based bottom side paint, but it was too late now. I ended up just painting on the next layer extra thick, and then sanding down the brushstroke texture. I bought a cheap belt sander for this, but that was too difficult to hold flat, so I ended up just doing it all by hand. But this was super difficult because sandpaper would clog up really quickly. This might have been a dumb idea, but I ended up doing fairing compound over the top of the primer. I'll let you know how it holds up over the next few years, but so far so good. Finally, the surface finish was looking smooth enough for the final paint, so I did another layer of primer on top of the fairing compound, and then after that dried, I started painting it yellow. In total, I did 2 coats of the yellow paint, and it was winter and very cold in the garage at this point, so I put the tent back up to help it cure. After a few days of curing, I flipped it over and finished painting the top yellow. And that pretty much concludes the build of hull number 1. Now I had to do it all over again for hull number 2. But luckily I had learned a lot from all the mistakes I made on hull 1, so hull 2 should be much easier and cleaner. And that held true. I won't go into depth for the build of hull 2, but I was sure to always wet out the surface before laying down dry carbon fiber, and when wetting out the peel ply I still used a heat gun, but I had the temperature turned way down. And that paid off. This time the carbon did not warp. I also felt like I did a much better job laying the carbon on the top side. I did almost all of it in one long day, and put peel ply everywhere. So definitely a much higher quality result. Still not perfect, but so much better than before. For the tips, I did molds for both the top and bottom this time. I was able to do fewer layers of carbon on the bottom than the previous hull just because I didn't have to almost completely sand through one of them. So that's probably going to end up saving some weight. This looks so much better than the last time. Still had quite a bit of fairing compound on the tips though. The surface from a uniform layer of peel ply really reduces the amount of sanding you need to do. But I still did a final layer of fairing compound and then sanded that down smooth. Here's the finished product before paint. I also tried to fill in more of the carbon weave texture with fairing compound to avoid the paint pinhole problem this time. And then I painted it, and now we have 2 practically indistinguishable hulls. Now it's starting to look like a boat. Damn. I weighed them both, and the lightest one was 28.5 pounds, or 13 kilograms. The heavier one was only a little over half a pound heavier than that. These holes are sealed, so to prevent them from popping like a balloon, I drilled a little hole in the battery well and put Gore-Tex membranes over them. At least I hoped they were sealed well enough to need this. Now that the hulls are complete, it's finally time to start working on the deck. The main structure to hold these hulls together is going to be 4 of these pieces of wood. I marked and drilled out some holes that will eventually get bolted onto the deck mounts in the hulls. In hindsight, this step was a total waste of time, but I laid down carbon fiber toe on the edges of all 4 boards to get a little extra strength. I pounded some of these spike nuts into the wood, which was also a mistake to do at this point, and to prevent these nuts from filling with epoxy, I 3D printed these little M8 threaded plugs. They screw right into the backside of the holes and into the nuts. Pretty slick. And I filled all the cracks and holes with clay to keep the epoxy out. Next it was time to reinforce the boards, so I started by cutting some fiberglass. Also a mistake. I should have just used carbon fiber, because I ended up using carbon fiber for the rest of the deck anyways. So basically I just wrapped this board with a few layers of 6-ounce glass, and then peel ply, and then breather cloth, and then vacuum bagged it. But that took way too long, and doing the remaining 3 boards would have taken forever, so as an alternative I decided to try out this fiberglass sleeve. It's usually used for hockey sticks, I think. It sped up the process, but it was really difficult to slide over the wood. It's kind of like those finger trap pranks. You can't pull it, you can only push it. I reinforced the area over the holes with extra glass and then finished sliding the sleeve all the way over the wood and fully wetted them out. Then they got peel ply and vacuum bag, just like before, and I let them cure in this electric sauna bag. The peel ply was really hard to get off. I should have used a separation layer between that and the breather cloth. Then I carefully removed the fiberglass from the holes and unscrewed the plugs. Oh wait, that didn't work. They were stuck. So I basically had to chisel them out. Then I pushed out the other side with a bolt. Here's all my reinforced wood getting laid out and getting bolted onto the holes. Feeling this wiggle made me realize that the deck portion that goes in between the boards was going to need to be really strong in the torsional direction. The next step was to connect each pair of boards together. Luckily, this inch-thick pink insulation foam was the perfect width, so I glued all the pieces together with Gorilla Glue and bolted it back onto the holes so that it would cure perfectly aligned. Then cleaned up all the extra glue and foam with a knife. Now it's time to fill in the deck, and for that I'm using 3-inch pink insulation foam. I hot wire cut that down to almost the perfect size and dropped it into place.
Oh, cut off too much.
I used hot glue to temporarily tack that down and then built a tape dam underneath the crack. That allowed me to pour in a lot of Gorilla Glue without it all just leaving. I'm using the same size of wood for the sidewalls of the deck, so I cut that to size and glued it in place, tacking it all with hot glue while the Gorilla Glue cured. After it cured, I removed the deck and brought it inside. There I mixed up some fairing compound and used it to make fillets in between the 3.5-inch wood and 3-inch foam. But after doing one of those, I realized that it was kind of unnecessarily heavy and expensive to smooth out the corners this way. So as an alternative, I decided to 3D print some molding strips that I could just glue in. Those made for a much nicer fillet. So I used the same technique for all remaining 3 corners. They're printed with a 10% infill, so they weigh much less than solid fairing compound fillet. And to round off the other side of the wood, I'm using an angle grinder with a sanding disc. I also used 3D printed fillets for the outer corners. These will make glassing over these corners a little easier. And finally, it's time to start covering the deck with composite. I used several layers of uni to stiffen along the axes of the main beams. This is why I previously said that fiberglassing the beams was a mistake. The carbon fiber is stiffer, so it's going to end up taking all the load, and the glass isn't really doing all that much. Oh well. Next I added quite a few diagonal pieces to hopefully give it some good torsional strength. Then some strips along the other side beams. Then even more cross strips after that. Finally, it was time for the plane weave. This is the bottom side of the deck, by the way. I'm just doing one layer of plane weave. Then came peel ply to improve the surface finish and soak up some of the excess epoxy. After that, I put it on the floor, added breather cloth, and built a vacuum bag around it using some cheap plastic painter's drop cloth from the hardware store. I'm just using cheap caulking to seal the top and bottom together. It seemed to hold a vacuum well enough. Then I threw the sauna bag on top to help the epoxy cure.
I gotta flip it over and do the other side.
I'm lucky that the vacuum bag didn't snap the unsupported boards. So for the next time around, I put these spacers in there to prevent them from bending together. And I also added more threaded plugs to the holes. On the top, it's pretty much the same story for this side, except I also started putting some carbon along the boards on the corners to add strength there. Now you can see why those orange fillets come in handy. It was kind of hard to get the layers to stick to the sides because of the protruding screw holes, but it worked out, and I'll end up reinforcing these areas a lot more in the future. And then the whole thing went in the vacuum bag.
Whew, that was a lot of work. It's now under vacuum. It only took me like 5 hours to get all the carbon fiber laid up. The vacuum's not perfect. I think there's no compression in the corners here, but it doesn't need to be perfect. I added quite a few layers of carbon to the sides of these boards here. That's not so bad. Wow.
After that, I just had to do a little cleanup sanding to prepare it for even more carbon. For this next step, we're going to need a lot of carbon fiber strips, so I made some, and then started layering those onto the edges. I was really worried that these areas would not be strong enough. For this layup here, I was testing if caution tape would leave a good surface finish, and it did certainly make it easier to compress the carbon fiber onto the board.
You can kind of work out the air bubbles too, make the surface finish a little bit cleaner.
On the other side, I did regular peel ply for comparison, with caution tape over that to help wrap it all together with the tape. It turns out that the side that says caution sticks to epoxy.
The heck, it's not supposed to stick.
But the back side does not. Note to future self.
The benefit to the caution tape is that it leaves a nice smooth surface finish, but I think I like the peel ply better, so I'm gonna do peel ply for the rest of it. And it's got this nice textured surface that either paint or more carbon fiber will stick to.
Next, it's time for more carbon fiber. This time to cover the wood on the edge. It's kind of difficult to get the carbon to lay down around the corner, but some extra peel ply over the top helps hold it down very nicely. Here I added some straps around the edge to help lock in the inner board down to the deck. If you haven't noticed, I'm just purely going off vibes here. Like, I just add carbon wherever it seems like it needs to be stronger. I did zero planning for the carbon placement on this deck, or the holes for that matter. Laying carbon into these corners is pretty tedious. I had to use really thin strips and follow them with really thin strips of peel ply.
The carbon is pretty thick in these 90-degree bends, so I'm pretty confident in the strength here.
Next, I 3D printed this handle out of PETG on the Prusa XL. Then I cut a hole of the same size into the bottom of the deck and picked out all the foam. Finally, I glued the handle into the hole. This should make the deck much easier to carry and get in and out of the car.
This is our skin in the center, 0.9 millimeters thick.
Then I entombed the handle in carbon fiber to lock it in place. That's still going to need some fairing compound and sanding. Speaking of fairing compound and sanding, the next thing I did was just that. There was a lot of little rough bits of carbon that needed smoothing out, but I won't bore you with too much of that. I had to drill out the bolt holes again, and it was at this point that I realized I definitely should have put the nuts on the outside of the carbon rather than on the inside. They were just going to compress the wood over time and pull away from the carbon. But oh well. Next I assembled it all for a test fit. By the way, the big things on all four corners of the holes are stands, so I don't have to put the holes down directly onto the ground. They're really convenient. Just big 3D printed plastic parts that I printed on the Prusa XL.
Okay, let's see if it's rigid now.
There was definitely a loud crack there, but I'm just going to cross my fingers and hope it was just the connectors slipping rather than the structure cracking. There's definitely some torsional flex going on, but hopefully it'll be strong enough. We won't know until I drive full speed into a big wake. That'll be an exciting day. When it's loaded down in the vertical direction, it seems plenty strong, even with two people on there. There's no way the holes themselves will ever crack in half. Later, I ground off some of the paint so that I could add some little mounting points. These will just allow me to tie the whole stands on so I can pick it up and move it around without them falling off. Now it's time for the deck surface. This is just some adhesive backed foam that happens to be made for boat decks. After that, I started painting the bottom. This is the same 1-part polyurethane paint that I used for the hulls, but just blue instead of yellow. And I did 2 coats of that. With a smaller brush, I painted right around the edges and up to the foam. And that concludes the deck. Now it's time to start on the motors. I'm going to use the exact same motors that I used for both the solar-powered Boston Whaler and the giant paddleboard hydrofoil from last summer. I'm also using the exact same foil masts that were on the hydrofoil. I'm just going to cut them down shorter. So all I really need to do is design the thing that attaches the mast to the boat deck. And for that, it was back into Onshape. This is what I ended up with. Basically just some big chunky 3D prints that hug the deck on one side and hug the mast on the other. I did add a pivot so that I can rotate the mast 180 degrees up for when I pull the boat out of the water or want to change the props or whatever. Here's the first thin wall prototype that I made just to do a fit check with. Seems to work alright, so then it was on to printing the real things with much thicker walls. I did a multi-material print where the part was PETG but the supports were PLA. PETG does not stick to PLA, so this makes support material removal easy. But on my first few tries, the PETG was warping away from the PLA, so that's why I had to add these support walls around the outside to hold the PETG down. That ended up working decently well, and the PLA supports slid out quite nicely. I printed everything in 2 halves, split down the middle, just so there wasn't as many unsupported overhangs. Then the halves all got glued and screwed together. Here's one of the bigger parts printing. I think I did like a 4mm wall thickness with 20% infill or something like that. On this one you can see the support kind of lifted off the build plate, but it ended up not really mattering. The weird looking holes in the sides are for nuts and washers. These get grabbed by bolts from the back, and this is how we will tighten the mount around the aluminum hydrofoil mast. I printed these mast huggers out of flexible filament in hopes that they will grip the mast better, but also possibly give us some vibration isolation from the props. More specifically, I'm using this Fiberflex 40D and printing it on the Prusa Mark IV-S. This stuff is much softer than other TPUs I've used. Those parts just slide into the middle, and there are 4 of them total. And then the whole assembly just slides over the mast. Then all 6 bolts get tightened to squeeze it in place.
Yeah, the bolts aren't even that tight, and it's on there.
I'm using this 15mm aluminum rod left over from the snowcap project as the pivot point for the motor mounts. That just goes through here, and then these pins hold it in place, though they don't work very well, so I need to figure out something else there. Here's the actual motor mast assembly that I had on the hydrofoil. I have to cut the mast down, so to do that I first need to take off the motors and get the phase wires out of the mast. That ended up being pretty hard. I had to pour mineral oil down the center of the mast to get the phase wires to slide out. But I finally did it, and then I cut the mast down with the miter saw. I also had to cut out a section of the sidewall so that the phase wires can come out of the side rather than the top. This is so that the mast can rotate 180 degrees out of the water and not just squish the wires when it's all the way up. Then it was time to slide the phase wires back through the mast and put the motor mount back on. Then the mast just slid up and into the new upper section. And just like that, our outboard is starting to take shape. To drive these motors, I'm going to be using these super sketchy Vesk 75-200s that got water damaged when they were on the hydrofoil. I feel like it's really misleading because everything is supposed to be fully potted on these things. They're advertised as being waterproof, and yet there's obviously corrosion in the power wire and phase wire pass-through areas. So the logic is on this top PCB, the power stage is on the bottom, and I think the power stage was what was all wet. After scrubbing off the corrosion, it seemed like the ESCs worked fine, so I decided to use them. The sketchiest part is that when I was cutting the enclosure off, the saw blade went through one of the capacitor enclosures. It seems like it's so close to hitting the electrolytics on the inside, but it still works, so we're going for it. I repotted them in silicone and designed these 3D printed enclosures to mount them onto the outboards, and those just bolt right onto the sides. So here's basically the finished outboards going onto the deck. But before bolting them on, I had to mark and drill some holes for the bolts to pass through the deck. And I also melted some of those spike nuts into the plastic so that they just stay there. These are very long M8 bolts. For the first test drive, I simply have two motors connected to an RC receiver as elevons. So it's just a simple remote control. No autopilot or anything like that.
It seems that these holes become occupied. Oh, yep, there he goes. Oh, get out of there. This is my boat.
Now it's time for the maiden voyage. I can easily transport both hulls on the top of my truck, and I sized the deck to be the maximum possible size to fit in the bed. So this thing is pretty easy to take to the lake, and you don't need to worry about a trailer. But the setup time is a bit longer than if you were to have it on a trailer, but it still only takes a few minutes to set up, so it's not bad. Eventually I want to make some skids or wheels for the front pontoon stands, so one person can lift it into the water by themselves. But for now it's pretty easy with two people. The hull stands can be removed once the boat is in the water, so that the hulls never have to touch the ground, because that would scratch them.
Oh, you forgot your life jacket.
Yeah. Oh no, we're going too fast. Let's put in the drag brake. Oh God, this is a one person.
Oh no! Oh no, come back!
There's a solo cup in the back of my truck. We might need it to bail out these battery wells.
Okay, I'll go grab it.
With both of us on there, the water line was a bit higher than I was hoping it would be. But to be fair, our combined weight is 350 pounds, so I think it'll be much better with only one person or two lighter people on board. So we lowered the motors, said our final goodbyes, and throttled up for the maiden voyage. It turns very slowly, like a container ship. This is not an agile boat. This is a boat for long straight lines. This boat is such a lowrider. Some thrust. Yeah. Damn! This boat goes. Oh, it's so good. And it turns. Look at that. Just barely enough, yeah. Oh man, I'm excited to take it over some big boat wakes now and just see how it does. This is Jonathan, our skipper for today. Our first mate. What's the second in command mate under the captain? Okay, we're doing a high-speed run. Woo! Oh yeah, this thing cruises.
Nice wake.
Yeah. Yeah. I just gotta not hit the ground. It also gets really shallow in here. All right, what's our wide open throttle speed?
We're reading 6.
6 miles an hour? That's it?
That's it.
We gotta be going faster than 6 miles an hour. Look, we're keeping up with that car. It's going like 60. Let's see if these guys are warm.
They're just lukewarm. The max current is set to only 100 amps, 100 phase amps, and I don't even think we're getting that high.
Okay, I got an app on my phone now.
Okay, we're going back up full throttle. Full steam ahead, Captain. 10 miles an hour. That's respectable.
I'd buy 10.
That's actually really fast for a little electric boat like this.
Yeah.
Especially considering,
trolling motor.
yeah, that we're probably not even pulling that much watts. Takes about 45 minutes to do a 180-degree turn. Just kidding, but it turns real slow.
We got off the boat at a swim platform and did another speed test. I was surprised that it really didn't appear to be any faster, even while 350 pounds lighter. I think that's just kind of the nature of displacement hulls. They kind of suck themselves down at higher speeds, so the weight almost doesn't matter. I think with some different props, we're going to be able to squeeze another mile per hour or two out of this boat, and increase efficiency by a lot. The current props are pretty inefficient. Overall, I was really happy with the performance. It turns very slowly, but perfectly well enough to navigate around the lake. This thing is going to make for a great cruiser and swim platform for the summer. I'll put those big 100 amp hour batteries on board with some lawn chairs, and I think it'll cruise all day. I might even use it for the next propeller design competition. Not sure. It seems that the Vesk has stopped working and we don't have any power. But we're right next to the dock, so it doesn't really matter. I do have a backup plan. We can take this 5 volts right here and put it back into there. That got one of the motors working, but the other was still dead. Not surprising considering the history of these ESCs. I weighed the hulls again after the maiden voyage, and they were 13 kilograms and 13.3 kilograms. So this goes to show they did not leak at all, which I'm very happy about. So in the next video of this boat, I'm going to be testing better propellers, doing range tests, efficiency tests, and more. So stay tuned. Oh, by the way, there's a very small number of the Signature Edition Flick Wings left in stock. So if you want one, check out the link. Oh, a fish just jumped right there. A little tiny one. That's cool. If you want one, check the link in the description to head to the Alight Wing store to pick up your Signature Limited Edition Black Flick Wing, because they will not be available for very much longer. I've started seeing quite a few YouTube videos of people flying FPV with their Flick Wings, and it sounds like people are absolutely loving the flight characteristics. So I'm really happy with how that design turned out. Anyways, I'm just paddling back. I went into the wind on the way that way, and I'm going into the wind back home. So I didn't get super lucky today, but oh well, that's how it goes. I'm not complaining. It's a nice enough day. Beautiful weather. Anyways, thanks for watching. Bye.